Okay, another technique we can use to get a little more mileage out of that power series is to use some differentiation, and also we'll also use integration in another problem, but here's how this works. Well, it would be hard to put this exactly like we were doing it in that form, because there's just, I mean, you could expand that, but then there's too many terms in there. I mean, this only works if you basically have a binomial term in your denominator. But here we have binomial squared, which means that ultimately it's a trinomial, right, if you pull that out. So this isn't quite going to work that way. However, the hint here is we are going to use differentiation. Because notice here, if I differentiate, so let's take 1 over 1 minus x equals the power series x to the n terms, the terms. We know that's true. If we take the derivative with respect to x of both sides, what do we get over here? Well, you got either quotient rule, or you can use the chain rule. Probably the chain rule is the easiest way to see it. If we take the derivative of that, the 1 minus x to the negative 1, bring down the power. New power would be negative 2 power times the derivative of the inside, negative 1. Ah, look at that. That's 1 over 1 minus x squared. Isn't that what we were looking for? Okay. So, this side's good. What do we got on this side? Well, actually, this side is fairly nice. Matter of fact, we can cut it all the way down to this, because that's just power rule, isn't it? Bring down the power. Multiply it by the new power would be n minus 1 power. So there's a good representation. Now, note here, if we start at n equals 0, what's the first term? 0. So that n equals 0 may not be necessary. And there's other things that we could do to that, but so you don't really need to include the 0 term if you leave it in that power. Anyway, okay. Now, so that was the most basic one. What about this one? Let's put it right here, so we have enough room for this one. X over 2 plus x squared. Use differentiation to find that power series representation. Well, for one thing, the x is, we can add it in later. So let's just work in. Let's just work on 1 over. Let's think about. Let's start with 1 over 2 plus x squared. okay? Think of that, that's what we're gonna think of first. This is where it kind of gets a little tricky. How are we gonna get that using differentiation? Well, if the ddx of 1 over 1 minus x equals 1 over 1 minus x squared, what do you think the ddx of what gives me that? Or close to it. Whoops. So this is kind of what we're thinking through. What function would it take to give me the derivative is 1 over this 2 plus x squared? Well, it's probably
1 over 2 plus
1 over 2 plus x. So let's start with 1 over 2 plus x. So that's what kind of gets tricky. You have to figure out, well, what do I need to start with here? In this case, yeah, start with 1 over 2 plus x, which that's 1 over, now we need to get the power series of that. So that would be what? This needs to be 1. So I need to factor off that 2 again. Oh, I think we did this one earlier, didn't we? So that's 1/2 times 1 over 1 minus negative x over 2. Now we know power series would be 1/2 times this power series. We might have done this one, matter of fact. So it's 1/2, and then this power series, since the x is replaced by negative x over 2, that's why I replace it in the power series. With me? Okay. All right, now, so that's the power series of that. But to get that, we're saying, what do we need to do? Take the derivative. So let's ddx are 1 over 2 plus x, and then ddx that. And let's write it. Let's write it this way. Let's separate it out like we did earlier. Okay? All right, so what is the derivative over here? Well, again, probably we'd want to go through, well, you can use quotient rule if you want, but it's also chain rule if we do it that way. So that derivative would be -1 times 2 plus x to the -2. And, well, chain rule is, the inside part's just derivative 1, isn't it? So we've almost got it. It's -1 though, so we'll have to deal with that. Now over here, what's that derivative going to give me? Well, again, I'm doing the derivative with respect to x, so this other stuff is just constants, if you will. And so that's just going to be 1/2 times the series, so you have -1 at the end. Power rule again. Bring down the power. The new power is 1 less. And again, I think we'd probably go off to 0. Won't do that. So what I didn't want, oh, okay, so a couple of things now. So this is not quite what I wanted. I've got -1 over 2. I want it to be x over this 2 plus x squared. So what do I need to do? Well, I need to multiply both sides by -1. And multiply both sides by x, don't I? Because that'll make that x over 2 plus x squared. Now, what happens on this side? Well, you can say that's -1 to the 1, then I've got a -1 to the n, so let's make that -1 to the n plus 1 times n. Then I got x to the 1, and I got x to the n minus 1, so isn't that going to be x to the n? And then on the bottom I got 2 to the first, 2 to the n, so that's going to be 2 to the n plus 1. So that's one possibility for it. And again, since n equals 0 would give me 0 for the first term, we could start it at n equals 1. And I want to say they want to do some weird stuff with these. That's what I would do with this series. Okay. Let's see. If we write those out, just kind of thinking that how else could we do it? Maybe it's not on this one. Yeah, I won't worry about that right now. But there are other possibilities that we could maybe change it if we wanted to start at n equals 0. That's what I'm thinking they might do. But anyway, anything on that? All right, let's do integration. Let's use integration. So this gives us another few other functions that we can get. The integration gets a nice one too. It's actually one, I believe, that's used in the next section. So let's use integration to find our series representation for ln of 1 minus x. See how that works. Okay, so here's what we have to note here. If I integrate 1 over 1 minus x dx, what that gives me is real close to what I want to get here. A little u substitution. Du is negative dx, so all right, so it'd be 1 over u du over negative 1. What is that? What's 1 over u du? ln, yeah. So you got the minus ln of u. So you got minus the ln of 1 minus x. So that's close to what? Well, all right, so Yeah. So here's, let's do it this way, okay. So let's say we've got ln of 1 minus x. That equals the negative, because let's just divide both sides by negative. Negative the integral of 1 over 1 minus x together. Right. Well, one minus x is, that's the power series. So basically now we're integrating this. Of course, we got the minus, little minus sign there. So what do we get here? That's actually a pretty nice little integral, because it is a summation. So we're integrating a summation. We can write it out term by term, but it's just going to be power rule, isn't it? We're just going to increase the power by 1. And the only other thing is I'm going to divide by that power. So yeah, so ln of 1 minus x turned out to be the integral of that, or negative the integral of that. So it becomes this power series. All right. I don't know what, I guess you just bring the negative in there with the 1.
There's not a plus c that you have to worry about.
Don't have to worry about the C on this one. See, I put it on this one, didn't I? Yeah, let's go ahead. Yeah, let's go ahead and put that in there, because it is an integral. So. Indefinite. This one might, it might come out to be 0. Let's think about that. X is 0. Yeah. Because look, if we do x is 0, that would make it ln of 1, right? And then this would be 0 to the power of, that's just 0 plus c. Yeah, I think that's what happens. So our series just comes out to be the series of 0 plus c. ln of 1 is 0, isn't it? So that's what it is. The c is 0. I was wondering why. I didn't have it on my notes, but that's why you don't have to worry about the c, because it's 0 here.
Is it going to be like that for all?
No. No, it isn't. Okay, so those are a little tricky. Let me do one more. So basically what we wind up doing is integrating both sides. So let's do this. I'll be all done. All right. So let's write ln of x plus 2. how do you think we're going to get ln of x plus 2? Probably by integrating x plus 2, right? 1 over x plus 2. Is that right? Is that true? I mean, a while ago it was almost that we just had a negative in front, but I think that's actually exactly, if you integrate 1 over x plus 2, use substitution, yeah, d equals dx, so you get the integral of 1 over u du, which is ln of u.
Yep.
X plus 2, okay. All right. So yeah, that's exactly a match. So, how do I turn that into a power series? Well, that's a little bit trickier. It's our little trick again. That needs to be a 1. You're going to factor off the 2. And then that needs to be 1 minus, so make it a minus minus x over 2. Right? Yeah. So we've got, the integral then is 1/2 times this power series, negative x over 2 to the end. Well, I guess there's a number of ways we could do it. But let's just factor it all out. Negative 1 to the n comes x to the n, 2 to the n. This then is just, isn't that just a constant, if you will, as far as the x, integrated with respect to x. So we got 1/2 times negative 1 to the n over 2 to the n. And again, that's just 1 over n plus 1, x to the n plus 1, and then plus c. Oh, I did the integral right here, so. Combine those, 2 to the n plus 1. There you go. Yeah, then you're asking about the plus c. In this case, if you do x is 0, find the c, we'd have ln of 2 equals the sum, all this would be 0 to the n plus 1, so it'd just be the sum of zeros plus c, so c would be the ln of 2, you see. So if we wanted to, we could make that little adjustment there. But anyway, they're fun going there. We'll see what you can do on those.